This video shows some photos of a Skywalker as I built it from a Hobby King kit. I thought this might be useful for anyone choosing to build this plane, especially because it's a great plane for FPV, very stable and lots of payload capacity. The kit came with a fuselage in two halves that you glue together and two wing pieces with a carbon tube to fasten those together. It had a number of wooden parts also, one to mount the motor, another to secure the horizontal tail, and another to attach the front lid compartment. The kit also contains some glue that I've read in other posts. People claim that it melted their foam. I didn't have that problem. Maybe it's the EPO foam that is immune to this now. So I ended up using that glue along with some epoxy and some hot glue. During the build, one of the issues was balance. I was warned beforehand that this would be an issue, and it was. If you build this kit, you'll almost certainly be slightly tail heavy, at least mine is. This might be offset with really big batteries, I'm not sure, but with my 4,000 milliamp hour battery set as far forward as I can get it, I still need about 150 grams of lead in the nose to balance everything. Here's a photo of the fuse length between the payload compartment and the tail surfaces. This section is very flexible, and there's a carbon rod that comes with the kit, or a carbon tube, and you have to put that in and glue it in along the channel that's provided in the foam. The kit also includes an adequate length of servo wire for the rudder and elevator, and there's a separate channel, or at least I think it's a separate channel, provided for the servo wires, and you can see in this photo that I've used one channel for the wires and one for the carbon tube. I've seen some photos of build-ups of this plane where people chose to route the servo wires through the carbon tube, and you can do that. I chose not to do that because to do it you have to cut some foam near the tail, and I'll show that in another picture. I epoxied down the carbon tube solidly, was generous with the epoxy, and then I just tacked down the servo wires in a few spots with some hot glue, and I think that works pretty well. Here's a photo of the interior of the tail section. I used the 9-gram servos here, and they fit perfectly in the holes that were provided. In this photo you can also see where I would have had to cut the foam if I would have wanted to route the wires through the carbon boom, which is why I just chose to route it along the upper channel. I tacked down the servo wires coming out of the elevator and rudder servos using some hot glue, and I did that right in the tail section itself. Those wires are not going to be long enough to run all the way to the payload compartment, and I didn't want to have those connectors buried in the tail boom. If the elevator servo or the rudder servo ever burn out, it's going to be a pain in the neck to replace those, but it'd be even more difficult if that connector was buried in the boom. All the surfaces in my kit were stiffer than I'd like, so I cut the surfaces free and then used bidirectional fiber tape to attach them and act as the hinge. You can see that in this photo on the rudder. At the top of this photo you can see the plywood piece that I've epoxied in. This is used to attach the horizontal tail using a couple of screws. In this photo you can see that I've used some wooden pieces to stiffen the compartment area. I epoxied them in. In retrospect, this is probably not necessary, but I intend to add various electronics, so just to be safe, I'm glad that I did. I used craft sticks and epoxy to do that, but popsicle sticks would work just as well. I'm planning to add an autopilot eventually, so the top compartment seems perfectly suited for that, the one just under the wing where the wing will be. But during my first flights, everything's in the main payload area. On the exterior of the payload compartment, there is a line drawn in the foam that indicates where you can draw or where you can cut a hatch to gain access to the interior cargo compartment. Because of the way I placed the sticks in the epoxy, I wasn't able to use that exact same place, but I drew my own lines and cut out an access to the electronics in the cargo compartment. That's important to do. Also, when you're cutting that hatch, you want to cut it on a bevel so that the hatch doesn't fall through. So if you cut the foam on an angle, it prevents it from going all the way through. At the bottom of the photo, you can see the plywood piece that comes with the kit. I've epoxied that into place, and it has a threaded hole in it and a screw that comes with the kit also, and that's what you use to screw down the front compartment lid. Here's the wing and the servo inside the wing for the ailerons. I cut the ailerons free and used the bidirectional fiber tape to act as a hinge on all the surfaces, and you can see it here as well. I'm not using flaps on this plane, but there are marks on the foam to cut those out, and those could be done the same way fairly easily. You can see here that the wires coming out of the aileron servo are not long enough to reach the cargo compartment where the receiver is. So you have to get some, you have to buy some servo wire extensions separately. I've tried to address issues that might have helped me during my build, but I'm sure I've missed some. Nonetheless, I hope this helps.